Okay, let us now solve this next question from the exercise 9.3 from the chapter of circles. Okay, so we are given that ABCD is a cyclic quadrilateral. So that means the four vertices of the quadrilateral lie on a circle. So we have ABCD lying on a circle. And we are given that the diagonals intersect at some point E. So the diagonals of this quadrilateral intersect at this point E. And we are given that the angle DBC is 70 degrees. So the angle DBC is this angle over here. That is given to be 70 degrees. And the angle BAC is 30 degrees. So BAC is this angle over here. That is given to be 30 degrees. And we are asked to find two things. The first thing we have to find is the angle BCD, which is this angle over here. BCD, which is this angle over here. That we have to find in the first case. And then in the second case, we are given a condition that if this line AB and the line BC are equal, then we have to find the angle ECD, which will be this part of the angle. Okay, so let's do the first part first, and then we will move on to the next part later. Okay, so first we are given that this angle, which is DBC, is 70 degrees. And we notice that this angle DBC is the angle subtended by the chord DC at the point B on the circle. So the chord DC is subtending this angle DBC of 70 degrees at the point B. And we know from the theorem that the angle subtended by the chord at any point on the circle should be equal. So if this chord DC is subtending an angle of 70 degrees here, then the angle subtended here should also be the same. That is, the angle CAD or angle DAC must also be equal to 70 degrees. So we have this angle over here, which I'm marking in red. That should be the same as the angle DBC. So let's write that down. So we have angle DAC is equal to angle DBC. So this angle here, DAC, is equal to DBC because they are both angles in the same segment of the circle. And we know from the theorem that the angles in the same segment of the circle are equal. So therefore, angle DAC is equal to angle DBC. And therefore, that should be 70 degrees as well. So therefore, we have angle DAC equals 70 degrees. Okay, now that we have angle DAC to be 70 degrees, we now know the angle DAB, which is the entire angle over here. DAB should be 70 degrees plus the 30 degrees, so that should be 100 degrees. So that is angle A is equal to 100 degrees. So now we will have angle A, which is equal to angle DAC plus angles BAC, which is equal to DAC is 70 degrees plus angle BAC is 30 degrees. So we have this as 100 degrees. So the total angle for angle A is 100 degrees. And we know from the property of cyclic quadrilateral that the sum of the opposite pair of angles in a cyclic quadrilateral is 180 degrees. So from that we can write angle A plus the angle C. What is angle C, by the way? Angle C is nothing but the angle BCD, right? So angle C, that they are the opposite pair of angles, and their sum should be 180 degrees. So angle C is nothing but angle BCD, and angle A is nothing but angle BAD. So angle A is the same as angle BAD plus, and angle C is nothing but angle BCD is equal to 180 degrees. And we can now write, or we can now find angle C. So angle C, which is nothing but the angle BCD, is equal to 180 degrees minus the angle A, which is 180 degrees minus the angle BAD. And what is the angle A or angle BAD? That is nothing but 100 degrees. So 180 minus 100, so you get 180 degrees minus the 100 degrees. So we get that as 80 degrees. So we have obtained the angle C, which is nothing but angle BCD, which is this angle over here, to be equal to 180 degrees, because for a cyclic quadrilateral, the sum of the opposite pair of angles should be 180 degrees. And since we have this angle here as 70 plus 30 as 100 degrees, that means this angle over here should be 80 degrees. So we have obtained this as 80 degrees. Okay, so we have solved the first part of the problem, which is to find angle BCD, which we have obtained as 80 degrees. Now we can proceed to find the second part of the question. So again, let's write down what is asked. So for the second part of the question, we are asked, or we are given that if AB is equal to BC, that is, if AB is equal to BC, find the angle ECD, which is this angle over here, ECD, which will be this angle here. So let's do it on a separate page. So we are given AB is equal to BC. So AB is equal to BC. We have to find ECD, and ECD is this part of the angle here. So this angle here is ECD, and this is what we have to find in the second case. In the first case, we have found the blue angle, which is the angle BCD. We have obtained that to be equal to 80 degrees. So this total here is 80 degrees, and we are asked to find now what is ECD given AB equals BC. Now, if AB and BC are basically chords inside the circle, and if these two chords are equal, we know from the theorem that equal chords subtend equal angles on the circle. So if the chord BC is subtending an angle BAC on the circle at point A of 30 degrees, that means another chord of the same length must subtend the same angle at any other point on the circle. So if AB and BC are equal, whatever angle BC is subtending here, AB must also be subtending the same angle over here. Okay, so since AB and BC are equal chords, we can say that the angle BCE, which is this angle here, BCE, the angle subtended by AB over here. So let me mark that with a different color, which is this angle over here, must be the same as the angle subtended by BC, which is this 30 degrees over here. Okay, so we know that this is 30 degrees. So angle BCE, which is marked in pink here, is the same as the angle BAC. Why is this? This is because equal chords subtend equal angles on the circle. And since we have angle BAC, since angle BAC equals 30 degrees, and that is given to us in the question, therefore angle BCE is also 30 degrees. So we have now the angle BCE, which is this angle here, to be 30 degrees. So if this angle is 30 degrees, we know that the total angle BCD is 80 degrees, and this part alone here is 30 degrees. So ECB then should be 80 minus the 30 degrees, which should be 50 degrees. So we now have the angle ECD, which is this angle that we are supposed to find out. That should be equal to the angle BCD, which is the total angle here, BCD, minus the angle BCE. And we have now obtained the angle BCE to be 30 degrees. So 80 degrees total minus the 30 degrees should give us the remaining part of the angle, which is ECD. So we will have this as BCD is 80 degrees minus BCE is 30 degrees. So therefore, we have angle ECD as 50 degrees. Okay, so this angle here is going to be 50 degrees. So we have obtained the second part of the solution as well, which is if the chords AB and BC are equal, then we are asked to find what is the angle ECD, and we use the idea that equal chords subtend equal angles on the circle. So if AB and BC are equal, they will subtend equal angles on the circle. We know the angle subtended by the chord BC on the circle as 30 degrees. So this is the angle over here subtended by the chord BC. So we should have the same angle subtended by the chord AB on any point on the circle, because AB and BC are equal in length. So the angle ACB or BCA, however we want to write it, that angle will be 30 degrees. Okay, which is the same as the angle BAC, that is. Okay, so when we are doing these kind of problems, we have to make sure we think clearly as to what is the information given to us and how we have to apply the various theorems that we have seen in the chapter. Okay, so in this case we have used the theorem concerning the equal chords, okay, concerning the angles subtended by equal chords. So if the chords are of equal length within the circle, then they subtend equal angles either at the center or at any other point on the circle. In this case, it is at a point on the circumference of the circle. Okay, so BC is subtending an angle of 30 degrees at some point A on the circle. Similarly, AB, which has the same length of BC, will also subtend the same angle of 30 degrees at some other point on the circle. Okay, so we have this as 30 degrees. Okay, and since we already knew that the total angle C is 80 degrees, we were able to find what is the angle ECB, which is this angle, as 80 degrees minus the 30 degrees, and we obtained that as 50 degrees.